unedited thoughts on tropical cyclones in general, with the context of looking at Hurricane Harvey, which is this storm that's about to hit the Texas coast. Hurricanes are one of my interests, along with all sorts of tropical cyclones and the Mediterranean tropical systems that we saw as well. So I'm going to discuss a few things about them and look at some of these sources. I'm going to be using Wunderground as well, because Wunderground have this great tropical section with lots of different data. They have satellite data, storm tracks, and advice from NOAA and so on. So Wunderground is a great resource that I would strongly recommend. What I've got up here is the Doppler radar, which sort of measures by proxy the intensity of the rain that's falling. So I mean, it's fairly intuitive that the red and orange is heavier rain and the blue is lighter rain. So radar is a good proxy for measuring rainfall. And you can see the structure of the storm quite nicely here. You can see the sort of clear eye, which has virtually no rain in it, and the sort of eye wall surrounding it, which is, I guess, stronger on the western side, with the heaviest of the rain rates. And then on the outer parts of the storm, you get these rain bands, these outer rain bands that sort of circulate around the storm. So a little bit about Hurricane Harvey and hurricanes in general. So a hurricane is a tropical cyclone. Tropical cyclone is the sort of umbrella term for all storm systems that form over the tropical oceans. And contrary to the extratropical cyclone, the tropical cyclone depends on these strong vertical temperature gradients. So to get a tropical cyclone or a hurricane, what you tend to need is warmer air at the surface, which is often achieved by having warmer sea surface temperatures that warms the air just above the surface of the sea, and cooler air higher up in the atmosphere. Whereas for extratropical cyclones, you tend to have these horizontal temperature gradients, where the sort of warm air rises above cold air that's undercutting it. So that's the main difference between tropical and extratropical cyclones. You need to have this interaction between the sea and the atmosphere to get intensification, the so-called sort of surface heat fluxes. So the fluxes between the surface of the sea and the atmosphere are what gives rise to the strength of the tropical cyclone. This is why you can't get tropical cyclones on land, because you need these surface heat fluxes from the ocean. Now, a little bit about categorization of tropical cyclones in general. So tropical cyclone is the umbrella term for all of these tropical systems, but it's subdivided based on intensity. So the weakest systems are called tropical depressions, which are disorganized regions of convection thunderstorms over the ocean. And then you have tropical storms, which are somewhat stronger, with wind speeds more than sustained about 40 miles an hour. Beyond that, you get hurricanes, or I mean, it depends on the geographical location. This is just a nomenclature thing. So hurricane for the Atlantic, you call them typhoons if it's the Western Pacific, and the cyclones for the Southern Hemisphere, but they're all the same thing. A hurricane, typhoon, cyclone, or whatever, is just a strong tropical cyclone with a wind speed of at least 74 miles an hour. And hurricanes, typhoons, etc. are further subdivided into 5 categories, which is the so-called Sareff-Simpson scale. Category 1, the weakest; Category 5, the strongest. And the categories are based again on wind strength. So again, Category 1, wind speeds of at least 74 miles an hour. Category 5, I think, is above about 155 miles an hour. So one thing about the category system is that these storms are only categorized in terms of their maximum sustained wind speed. That usually correlates to damage. So the sort of the higher the category, the more damage you'd expect. But it can be counterintuitive, because this is only talking about the maximum sustained wind speed achieved anywhere in the cyclone. It doesn't tell you anything about the distribution of wind speeds, and it doesn't tell you anything about the storm surge. It doesn't tell you anything about the rainfall, which is why the damage created by storms is not necessarily contingent on the category of storm. Not that isn't important, but to give an example, Hurricane Sandy 2012, highly devastating storm that did an awful lot of damage, but was still only category 1, weakest. Whereas Hurricane Patricia, which affected Mexico in the Eastern Pacific, was the strongest East Pacific hurricane on record. It had wind speeds of over 200 miles an hour, and as far as I'm aware, I think this was the second strongest tropical cyclone of all time. So an extremely strong system. It did next to no damage, and the reason for that was that it had this extremely tight wind field. So all the strongest of the winds were concentrated in the eye wall. That's the area directly around the eye. And because the wind field was so concentrated, the damage was limited to a really tiny area. And also, of course, Patricia, the thing about Patricia is it decayed very quickly when it came into land. So that's also another thing you've got to bear in mind. How quickly does the storm decay? And this is part of the reason that Hurricane Harvey is going to be such a big problem. It's not predicted to dissipate rapidly at all. So this is one of the problems with the system. It's becoming very slow moving. So you can see that there are these rain bands dumping an awful lot of rain over the Texas coast, continuous rain over a long period of time. Whereas, of course, a storm that moves through faster is going to deposit less water. So these kind of things are important, and also storm surge, of course, which does a lot of damage as well. I want to talk a little bit about the brown ocean effect. This is sort of more of an interest, an intrigue more than anything else. But the brown ocean effect, I mentioned earlier that you need these surface fluxes between the surface of the sea and the atmosphere in order to get these tropical cyclones. But that's not strictly always the case. There's actually very, very rare circumstances in which hurricanes can actually intensify over land. And these are vanishingly rare cases. But what happens is if you get significant amounts of soil moisture, you can actually get very strong heat fluxes between the soil and the atmosphere. And the reason it's called brown ocean is because the soil kind of functions like an ocean. And on the requirement for this to happen, again, it depends on the topography. So you don't want any mountainous terrain. You want extremely saturated soil, and the effect can't last very long. But nevertheless, this does happen. The main place that it happens is in Australia. Actually, there are actually tropical cyclones that move over the coast of Australia that actually intensify. So this is not unprecedented, and I'm mentioning the brown ocean effect because not necessarily saying that this thing is going to intensify over land. I'm sure it won't, but the point I'm making is that you can see that the amount of rain that's falling over this region. What could happen is that because the soil is so moist, that even when this system moves over land, the decay could be a lot slower than expected. I'm not saying it's going to intensify, but the decay could be a lot slower, particularly since the circulation, not all of the circulation is going to necessarily be over the land. So most hurricanes, typhoons, etc., when they move over land, they decay very, very quickly. But this is not going to happen with Hurricane Harvey, again, for two reasons. Firstly, because it's of the close proximity to the ocean, and secondly, because of this potential brown ocean effect, where these fluxes from the moistened soil. Again, keep in mind that the rain has been falling now over the soil for a long period of time. These fluxes over the soil can potentially delay the weakening of the storm. So that's something else to bear in mind. And when you take into account all these factors, what you've got a storm system that is going to last a long time. And when you think about accumulated damage, time is a factor. So a storm will do more damage if it lasts for longer because it has more time in which to do that damage over. So again, this is quite an important factor, which is going to make this particular storm so dangerous. And of course, even if it does decay, the amount of moisture that's bringing ashore means that we could see rain falling for 36, 48 hours, if not slightly longer than that. Now, anyway, I'm going to go into a few more specifics of the storm itself. And again, I highly advocate this website. It's called Wonderground, and they sort of collate all the information about various tropical weather. I always use Wonderground for this kind of thing. So again, we've got a basic track here. System is currently a category 3, and it's projected to move over land and then sort of store. There's not much. The sort of upper level winds, which sort of dictate where the storm moves, are so weak that the storm is not going to move very far at all. So because of this, we've got this storm stalling over just inland of Texas, and then it's actually going to sort of move back out towards the sea. And there's a lot of uncertainty about this track, whether it's actually going to move over the ocean again. And again, there's always a possibility of re-intensification, or like I mentioned with the brown ocean effect, we could expect it to stay hurricane status for a longer period of time. So they also have satellite imagery, which is quite nice. This is the visible satellite image, and you can see that I think relatively recently we've started to see the eye clearing out. So one sort of mark of a stronger storm system is that you tend to get, in weaker systems like tropical storms, you have a cloudy eye. Or of course, in a tropical storm, you might not even have an eye at all. But as the storm intensifies, the eye tends to become clearer, and it tends to warm as well. So you get these very cold clouds surrounding this quite warm eye. Relatively recently, we've started to see this warming of the eye, this clearing of the eye. So the clouds are sort of dissipating over the eye as well. Another thing to talk about, actually, as we're talking about the eye wall and the eye of the storm, is something called eye wall replacement cycles. Now, eye wall replacement cycles are not actually well understood. What happens is that a mature tropical cyclone, the eye wall doesn't last continuously. What tends to happen is that you tend to get a secondary eye wall that forms around the first eye wall. I mean, I'm not sure you can see it here because it's already happened, but so I think we need to go further back to actually see this. But yeah, so it's already happened, but I'll try and explain it anyway. What you get is you get a secondary eye wall that forms around the primary eye wall. So you get two eye walls, these concentric eye walls. So you get a one that forms around the outside, and then you get an inner one. And the one that forms around the outside starts to contract and destroy the inner eye wall. So the inner eye wall gets destroyed. This is called an eye wall replacement cycle. So essentially, it basically means that the eye wall is being destroyed and replaced with another eye wall. It's not really understood a great deal about why these eye wall replacement cycles happen. Nevertheless, they do happen. And during an eye wall replacement cycle, the tropical cyclone tends not to intensify. So we tend to get this period of stagnation where intensification doesn't occur during these eye wall replacement cycles. That being said, an eye wall replacement cycle should not be taken as being indicative of the storm weakening. This is a quite natural process of mature and indeed quite strong tropical cyclones. But nevertheless, the wind speeds do also tend to decrease. So it's not that the storm is weakening, but as a result of this process, the wind speeds do actually decrease. But as people have pointed out, it also means that the wind field tends to expand when you get these eye wall replacement cycles. So it's not necessarily a good thing. I mean, there's advantages and disadvantages to this. But as far as I'm aware, the eye wall replacement cycle has already happened. So, I mean, I can't see much evidence of it on this radar chart. But I was looking at radar images earlier, and I did actually see these concentric eye wall structures. But it seems that the eye wall replacement cycle is finished, which is why I believe we've only just now seen this quite rapid clearing of the eye. Because after the intensification wasn't actually going to occur during the replacement cycle, but it occurred afterwards. So we saw the intensification occur afterwards, which is why I think we've seen some quite rapid recent intensification. So I mean, I'm just looking at these. I think this is based on flyover data, so planes that fly into the storm and sort of gather information about it. Here we go. So we can see that we've seen quite a rapid increase in the wind speeds from about 110 miles an hour to 125 over a relatively short period. So we can see that actually from about 5 o'clock GMT to 10 o'clock GMT, we've seen an increase in wind speed of about 15 miles an hour, which is quite significant. But you'll see that there's also quite a significant period from 11 GMT to 6 at night, 6 GMT, where the wind speeds don't increase, but the pressure does still reduce. And I believe that during that period, we had this eye wall replacement cycle. So that kind of explains why, even though the pressure actually went down, the wind speeds didn't go up, didn't increase that much. And actually, we've seen the pressure seems to be bottoming out a bit while the winds are still intensifying. So again, the storm doesn't seem to be intensifying that much more now, but the winds are still increasing because of the completed eye wall replacement cycle. So I think that explains that. I'll have a look at the computer models and see what they. Okay, that's not working in some models. Not all of this is perfect, of course. 5-day forecast. Storm details. Yeah, it doesn't give. Okay, here we go. So this is NOAA's storm forecasts. So what they're saying, Harvey central pressure will also continue to fall, and the latest estimate based on dropzone data is 941 millibars. So that's a very significant system. Yeah, okay, so to summarize, this is gonna make landfall relatively soon. I mean, I can refresh the radar actually and see how much progress we made. Yeah, so the eye wall is actually pretty much making landfall now. You can see the eye wall structure making landfall. So when it does make landfall, I would expect to see a gradual weakening of the storm, but a lot slower than you would be typical for the reasons I've explained. So I hope I've given us some kind of indication about why Hurricane Harvey is going to be a particularly severe storm, despite only in inverted commas being a category 3. Compared to say category 5s, which don't, which have done less damage. Again, not to disparage the category system. The category system works fine. It's just that there are other considerations here. Anyway, those are my thoughts on Hurricane Harvey. I hope this has been informative. Feel free to write any comments in the comment section, and thank you for watching.